These have to be monsters. They're not that bad. They're not. We just have to reason our way through it. And usually when I encounter a problem in a section like this where I know, oh my goodness, there's going to be a lot going on in this problem, I ask myself this question. I read through it. I say, what do I know absolutely nothing about? Because that has to be my variable. That's my starting place. What do I have no information about? Close friends, Stacy, Una, and Amir were all born on July 4th. Strange coincidence. Stacy is 1 year younger than Una. Una is 2 years younger than Amir. On July 4th, 2010, the product of their ages was 2,300 more than the sum of their ages. And of course the question is, how old are they? Of course. All right, we have Stacy, we have Una, and we have Amir. Who do we know nothing about when you read those first two sentences? Blank slate. Who is it? Okay. We know nothing. They keep talking about Amir, but they don't ever tell us anything about Amir. They tell us about Stacy and Una and how they compare to Amir. So Amir is going to be our x. His age is our x. Now we think backwards. Okay, so they told us stuff about the other two based on this. It says Stacy is 1 year younger than Una. Well, I'm starting with Amir, so I'm not going to use that one yet. Una is 2 years younger than Amir. Oh, got it. Una is x minus 2. Has to be. All right, now I'll back up to find Stacy. Stacy is 1 year younger than Una. So what would she be? X minus 3. But she's a year younger than Una. If you subtract one more, there it is. Here it comes. The product of their ages. Was, is. I hate to teach Q words, but in math that means equals. You know, when it says this was, this is, it's like you're stopping on that side and you need to take a look at the other side. 2,300 more than the sum of their ages. What does sum mean again? Adding. So we're going to have to take 2,300 and add that to all of these ages right here. Add it up. Well, I'm not going to be able to fit all that over there, so I'm going to go ahead and add them. X plus x plus x, negative 2 and negative 3, and I'll put that down here. Oops, 2 for 3. All right, we can't figure out what's going on here until we have this in polynomial form. So that means we're going to have to do the multiplication, we're going to have to do the addition and all of that. So we'll start over here by doing some FOIL. And then a little bit of combining like terms over here. Not that, because I still need to distribute my x. Now you stop and you ask yourself, what am I really trying to do in terms of math? I'm trying to solve. I mean, I want an answer. I'm solving. Okay, solving. Solving is finding the zeros. Oh, I have to have a 0. So I'm going to have to subtract the 3x and the 2295. So we'll get x cubed minus 5x squared plus 3x minus 2295 equals 0. Whew. That's a polynomial. All right. I always want to do it by factoring if I can. So let's see. If I did this, I'd have to do factoring by grouping because there's no greatest common factor. In the front, I'd factor out an x squared and get x minus 5. Oh, goodness, is that never going to happen in the back? That's a nasty one. If we can't do it by factoring, then we have to let Blinky tell us, or the table. So we're going to let the table or Blinky tell us. Alrighty. Y equals x to the third minus 5x squared plus 3x minus 2295. I'm just going to hit zoom 6. You know, maybe we'll get lucky and maybe all these people are from 0 to 10 years old. Probably not. And the answer is not. You see absolutely nothing with the normal window. So, I wonder, I'll try, how about 0 to 30 years old? Let's try that. I mean, we can always keep increasing it, and eventually people do die. So, you know, if we went to 100, we definitely have. Oh, there it is. Now here's the problem. If we do this with Blinky, it's going to be impossible to see him in a couple of spots. So when you know it's perfectly hitting something, your best bet is to do second, trace, and go into the table and find your 0, which in this case is Amir's age of 15. Now, does that mean you can't use Blinky? No, it just is kind of tricky. So second, trace, number 2, I'm finding the 0. Now, there he is. I hit the left arrow, and it's like, what? Where'd he go? Well, look at the numbers down below. He went super duper low is where he went. I can still hit enter because I know I'm to the left, so I hit enter. Now I hit the right arrow once, now I can see him again, and I hit it one more time, and now where'd he go? Well, look, he's up there at 172.6 something. But all I need to do is hit enter and enter through guess, and Blinky will tell me it's 15-0. You just have to rely more on the numbers across the bottom when you do that, or you change your y values. In this one, you might have to go as high as like 100 or so in order to be able to get a better look at the curve that this has. So if you watch the numbers down below, you should be okay. So I don't think we answered the whole question. We've got Amir, but what about Una and Stacy? We need them. So how old is Una? 13, 2 years younger. And how about Stacy? Oh. Oops, I gotta spell Stacy's name right or she'll get me out of me. And abbreviate it correctly. My hand is not keeping up with my brain. There we go. So Amir is 15, Una's 13, and Stacy is 12. And it all starts with, who do I know nothing about? Because that has to be my variable. And then I have to build from that. So now, normally, on a day like today, I would give you the got it problem and give you a candy partner and have you go do the next problem. But this is a totally different problem. It's like we're starting over again. So I want to make sure that everybody's able to do this. What are 3 consecutive integers whose product is 480 more than their sum? To do this problem, you have to know what consecutive integers are. Consecutive integers are numbers like -4, -3, -2. They're right next to each other. 5, 6, 7 are consecutive integers. So I realize I should make the smallest one an x. And then think, how would I get to the next integer? So basically, what do you do to 5 to get 6? You add 1. And what do you do to 5 to get 7? You add 2. So that's what's going to represent my 3 numbers. The smallest one, the next one, and the one after that. So their product, we knew that was coming, x times x plus 1 times x plus 2 is 480 more than their sum. So we need to add these up again. X plus x is 3x, and 1 plus 2 is 3. So same steps as last time, you just have to think your way through what do we use for representing those consecutive integers. So we're foiling and combining like terms. We are distributing. We are realizing we're trying to solve. We need 0. So we're going to have to subtract 3x and 483 from both sides. And x to the third plus 3x squared minus x. That doesn't look like an x, it's very weird. Minus 483 equals 0. You think there's a chance that's factorable by grouping? It's like rotten 483 in the back. You know, those big numbers in the back. The rest of it, yeah, it's all look nice. Ugh, negative 483, where did that come from? So it is graphing calculator time. X to the third plus 3x squared minus x minus 483. I'll try zoom 6 again. Maybe these are smaller numbers. Ooh, there it is. Second trace, which is our graph, or not trace, second graph. Aha, my smallest number is 7. So what are the other two? A 9, yeah, they have to be. Also could use Blinky. Second trace, number 2, but again, look at where Blinky is right now. 0, negative 483, Blinky, what are you trying to do? So I'm going to have to right arrow until I see Blinky getting something close to 0, something reasonably close to 0. Come on, Blinkster. Yep, missed it. All right, so I've got to stop at negative 35 because my next choice is above the x-axis. So enter, arrow to the right once, enter through guess. The Blinkster pulls through. Gets us what we need. Well, like I said, really, if you're having trouble with that, make your y's something really big. And usually it'll start to look more like a curve. Not much with this one. I mean, we might even have to go to 1,000 to get this to look like a curve. But it helps a little bit with seeing Blinky when you do that. Alrighty, so objective today was that we wanted to be able to tackle the word problems because we have already done the solving by factoring and the rest of this. So 4, 3, 2, 1, 0 me. 2 new kinds of word problems here. How'd you feel, Claude, as we're working through them? Yeah, I can tell some are still thinking, it's still a word problem. Oh, I'm a little scared. It's okay. You'll be all right. They don't bite. Well, usually. If your word problems start to bite, let me know. We have a school psychologist I'd like to introduce you to. But there is that. Now, I've got to check the clock here because we're supposed to do it.
Oh, don't have time.
Ah, you do. That's good news. So I will enable that little bad boy. So once you have that written down, you can work it on it.